Hello, folks. Today I want to look at this question. We call it text justification. It's a hard question. It's a LeetCode hard question. It's pretty hard, but it's not undoable. Once you understand the rules, it becomes pretty simple. The rest is to handle a lot of tests like edge cases, and then you're pretty good. So let's look at it. Given an array of strings, words, and a width matched with, format the text such that each line has exactly matched with characters and is fully left and right justified. You should pack your words in a greedy approach. That is, pack as many words as you can in each line. Add extra spaces when necessary so that each line has exactly matched with characters. Extra space between words should be distributed as evenly as possible. The number of spaces on a line does not divide evenly between words. The empty slots on the left will be assigned more spaces than the slots on the right. So what it means is you are given this line of words. What you have to do is then you're also given max width. Max width is simply the number of characters that must go into each line, including spaces, of course. Spaces are counted as characters. So that's it. So all that you have to do is the way to go about this question is pretty simple. All that you have to do is at first you put the words there, and then after each word you have to put a space. After each word you have to put a single space. So after you finish, you have words with single spaces between them. Then you count the number of characters, including the spaces. So, but you have to make sure that it doesn't exceed max width. It doesn't exceed this. So let's say it is 16 here. Make sure the number of characters doesn't exceed the 16, whether it's less or equal to 16. So once you realize that if you add an extra word, you're going to exceed the 16, then you stop. You don't add any more words. You stop there. And if you stop there and then the length that you have, the number of characters you have is less than 16. But if you add an extra word, it's going to be more than 16. You don't add extra word. All that you have to do is to subtract the current number of characters that you have from max width given. So after subtracting, you find the number of spaces that you have to add to that particular line. And then you divide that spaces among the gaps that you have in the line. So let's say here you have 3 spaces. You add one extra space to this place, and then you add an extra space to this place. Then that single space that's left, you give it to the leftmost one. And if no extra space is left, let's say you have to distribute 2 spaces, then you just give here 1 and give here 1, and then that's it. But if it is 3, you give the leftmost 2, then the rightmost 1. So you prioritize the left to the right. So that's the whole code that I've just talked about. So let me just dive into writing the actual code. It's pretty simple. Let's dive into it. So I'll define output, which is equal to this. It will be what we are going to be returning. And then let me define other variables. And the variable that I call line is going to be a temporary variable that will hold each line as we build it. So once we finish building it, we append it to output, then reset this variable to build another line. And another variable I call line length is just going to be the length of this line. That's basically it, and it's 0. And then the line is an empty list, and then output is an empty list. So now let's define a variable called I. That will help us to go through the input voice. We're going to go through all with the help of this I. So now let's start a while loop. While I, as usual, is less than length of words. Right. Then we're going to check. We're going to check if that particular line is complete. If we cannot add any more lines to the word.
Then we calculate the number of spaces we need. And then we distribute the space among the line and then append it to our final result. So now we're going to check if the line is complete. So if line length plus length of line plus length of words of I is greater than max width. So what this line is doing is line length is the length of that specific line that we are working on. You might ask, why are we adding this? We're adding this because after each word, you need to add an extra space. So this just counts for the total number of characters in each word for that same line, excluding spaces. So this accounts for the spaces. And then this also accounts for the current word that we want to add. So if it's greater than that, then that means word is complete. That means line is complete. Line is complete. So now what we have to do is to calculate and distribute spaces, right? So we calculate and distribute spaces. So if the line is complete, we need to calculate the number of spaces we are going to give to each gap. And then after that, then you give those spaces to them. So now let's calculate. So total spaces is equal to, so we are not going to calculate the total spaces that we are going to have. So it's just max width minus line length. Remember, this is the length of the line without spaces. So we subtract that from max width to get the number of spaces we have to distribute. So now let's find the variable spaces per gap. Very explanatory. So for each gap, so for each single gap, how many spaces are we going to give to it? That's this one. So spaces per gap is equal to, it's simply equal to the total spaces, right? Divided by length of line, which is the number of words, right? Because after each word, you're going to put a space there, except the last line. So let's subtract one from this. Because after the last line, you're not giving any extra space. But if word is empty, this is going to give us, if the line has no word, this is going to give us error, division by 0. So let's get very smart and do this. So that if the length of the line is 0, we don't divide by 0, but we rather divide by 1. So we keep it as it is. So that's the total space. And now let's find the remainder. Remember, when the number of spaces is not evenly divisible by a number of gaps, we need to prioritize giving more spaces to the leftmost gap. So let's say this one, which has 2 spaces. If you had 3, this has 2 gaps, right? But if you have 3 spaces to distribute, you're going to give this part 2 spaces and give this part a single space. So that's why we're calculating the remainder. So remainder is equal to this. Of course, this will be modulus and everything else the same thing. So that's basically it. So now let's distribute the space. Now we have this total. Now we have the spaces per gap. We have the remainder. All that we have to do is to actually do the distribution. So distribute spaces between words. So now let's go ahead and do that. So now you're going to go through that specific line and then distribute the spaces in that line. So you're going to go through and make sure the spaces are
as they have to be. So for J in range max of 1 and length of line. So if the length of line is 0, then we make sure our loop executes 1 time. Because if you don't do it this way, then our loop will not execute at all. So minus 1. All right. So you just subtract 1 from it. And then the next thing you have to do is just go ahead and then continue the distribution. So now you run a loop, you're going through the whole line. So now we just distribute the spaces. So line of J plus equal to a space, right? But we need to multiply by spaces per gap. Because let's say there should be 5 spaces for that specific gap. We need to multiply the space by 5. So you get our 5 spaces and then give to the gap. And now if there is a remainder, we prioritize the left. So if remainder, if remainder, if remainder is not 0, that's if there is a remainder, then give it to the left. So line of J plus equal to a single space. And the remainder we reduce it minus equal to 1. So we've come this far. Let's go ahead. So now we need to join the line, and then after join, then we have to append it to output, right? So now we are done with distributing the spaces. So what you have to do is to join line and append to output. So now remember we are working with a list, but we need a string. So we need to join it into a single string and append it to the output that we have. So output dot append this dot join the line. So that's all we have to do here. And then after appending the line to the result here, after appending it to the output, that means, let's say this one, we're done with the first line. Now we need to reset line and then start all over again and build the next line. So all that you have to do is reset these variables. Reset these variables. We are not resetting output actually. So that's it. Because you remember, output is just something that's supposed to accumulate the whole results and return. So we are not resetting that at all. So line will reset line length. Obviously, we'll be resetting it. So now all that we have to do is so remember, if the line is complete, we do all this. But if the line is not complete, we are not even doing any of these things here because the if condition will be false, right? So all that we have to do is to add next line. No, add next word to line. Add next word to line. So if this condition is false, we don't even do any of this. We just add next word to line. We continue to add the words until the line is complete. Look at this one. Until the line is complete, that's when we do this if condition. So if the line is not complete, you're not even doing this if condition at all. You're just doing this. And even if the line is complete and we finish executing this, we will still come to this place anyways. Because remember, if this and it executes, you are definitely coming to this place. So whether the line is complete or not, you have to add next word to line. But the difference is that if the line is complete, you do all this. and then reset line and then line length before we add next word to line so that we build the next line. That's when it's complete. But if it's not complete, we don't do this. We just come and do this. So if it's complete, we do this and come and do this. If it's not, we just come straight to this place. So that's the difference. So whether this executes or not, it won't prevent this from executing. So let's go ahead and then do that. So it's pretty simple. So add next word. So it's just like line dot append next word, right? Dot append next word. And then what's the next word? Next word is just word of I. Remember. After that, what do we do? After append the word, we need to do what? Line length. Line length. Length plus equal to. Is it going to be 1? No. It's going to be length of words of I. Because remember, there are many characters in a single word sometimes. So we just find the length just to make sure if it is more than 1, we include all the characters there. And after that, we need to go forward, right? So I plus equal to 1. So we are almost done with everything. And remember, the last word has its own rule. It's supposed to always be left justified. It doesn't go with the rules for the above. It just has to be left justified. What it means is that if, let's say, there are 5 words in the last line, there should be a single space between each word. And if after that we have, let's say, 6 more spaces left, we put all the spaces to the right of the words and we are done. And that's only for the last line. So now we're going to handle that last line. So let's handle that. So last line, left justification, you're basically handling that. So let's go. So last line, AKA left justification. Nice. So now let's just create a variable called last line. And it's equal to space dot join line. Remember, if you build a line, if it's for the last line, as I've already discussed, as I've already said, left justification. So line dot join. So we just join the line and then let's call something trail, like trail space. Trail space is the space that you have to add to the right side. It can be 0, it can be 10, it can be anything. So we just add it here. So let's find that. So trail space is equal to, just as we did above, how we find it's max width minus. But remember, this one is going to be max width minus length of last line, because last line is the number of characters already present in the line. So we need to subtract that from max width so that we need a number of spaces to add. So now we're basically done. You just have to output dot append our last line, because that's what we calculated, right? Yeah, our last line. But remember, we need to add that space that we calculated, right? We need to add that space that we calculated. But remember, this is just a number. We can just add a number, right? So all that we do is to multiply it by that number of spaces that we need, like this. So if this is 5 spaces that we need to put at the end, 5 times a single space. So we have 5 spaces, right? So it's basically that. So now all that we have to do is to return our outputs. But you think about it. Oh yeah, we just return our output and basically that's it. Because it's supposed to be a list, right? So it's a list of strings. So we are basically done. Now I'm gonna run it and see if I made an error. Line length is not defined. It do mean line length. I typed something wrongly. Line length. Oh, it's supposed to be a capital N. Word is not defined. It do mean words. Okay, it's worse. Less index out of range. Okay, what did I do? Line of I plus equal to items spaces per gap. So for I in range max of 1 and line and length of line minus 1 line of I. Yeah, I'm supposed to make it a J because see J here. Nice. Okay, now it's working. Let me submit it and see. Nice. Now everything is working and it's pretty efficient, as you can see. It's efficient with both time and memory. And for time complexity here, remember, we are going through all the input list, that list of strings. We are going through all, and that is big O of N. So we're going through all this while loop. And this is a condition that we check alongside. And this is a sub condition that we check for each line. We distribute the spaces on it. So you think about this one. We go through each line. We will go through all the input words. That alone is big O of N. This is just a simple condition that we check as we go through. So that doesn't matter. Now let's check this one. So for each word, we build the word. After building the word, we go through it again. After building the word, we need to go through it again to distribute spaces. So building the word itself wouldn't have been anything because it's part of this. As we go, we build it at the same time, but we have to go through it again and redistribute spaces. So it's more of big of N as well. Because you think about it, for the input, we go through all that's big N. And for each single line, we go through it again and then calculate the number of spaces. Sorry, and then distribute the number of spaces. So we do that for each single line. But if we add all the lines together, that's equal to the length of the input list. So that alone is big O of N. So nested inside this while loop. So the time complexity is likely big O of N squared here. And for space complexity, we are storing this and that. Each one is big O of N. So output is obviously big O of N, right? Yes, but we is supposed to store all the words that we had. And per line here, you're going to have multiple. We're going to have, so that's going to be likely big of N because we're going to have line for, so we're going to have some number of lines. And the number of lines, the number of words inside that number of lines, we combine all the number of words and the space and everything is going to be equal to the length of input words. So the time complexity should be something like big of N. So big of N plus big of N is also big of N. So something like big of N squared for time and big of N for space, something like that. Okay, so thank you for watching. If you like the video, smash that like button and subscribe. Hit the notification bell. Thank you so much. Have a good day.